That is correct. All right, I want to give you a quick introduction to an idea. This is a new idea. Well, it's a new idea in that we haven't really talked much about it in class. Maybe you've noticed something like this or heard it from someone. They're called parametric functions. With an emphasis on the fun. So it goes like this. Normal functions, our regular functions, are y is equal to a function of x. That is to say, y is dependent, and what it depends on is x, so we call x independent. And typically the way we initially think of this is we allow x to be whatever, so we make these little t-charts, maybe you remember these, and we pick some random values for x like -3, -2, -1, and those values for x determine the value for y. And in this manner we think of y depending on the value of x. That's what all that language means. We're going to add a little twist to that, and that twist goes like this. Now, instead of having y depend on x and x be independent, we're going to have two dependent, wow, sorry for my spelling, two dependent variables. That is to say, we're going to let both x and y be dependent. We're going to have some other independent variable that's not x or y. Typically, we can use anything we want. We can have x and y both dependent on any variable. So think of a variable. Got one? Okay. Did you pick t? Oh, maybe you did, maybe you didn't. Doesn't matter. T is a pretty common choice, and you'll see why as we kind of move through these. So now we think of t is now the independent variable. Wow. I can't spell. That doesn't say independent on the paper, but what I said was independent. And x and y then are both dependent. Whew. Pretty simple, I think. So when we go to play with these, and we'll do that in the next video. So when we go to play with these functions, instead of picking random values, as you recall, we take our independent variable, pick some random values, and that generates values for the dependent variable. We're going to make a bigger chart. Now we'll pick random values for t, and that will determine the values for x and the values for y. For example, I'll do a really quick example here. For example, suppose x was equal to 2t plus 1. Y is equal to -t plus 5. Big nice little linear values here. That means if we wanted to see what this looked like, we go whoop, whoop, bloop. -1, 0, 1, 2, x, y. I just pick those randomly. Doesn't matter. You can pick any values you want, whichever ones are convenient. That means x will be, oh boy, -1, 1, 3, 5. Pause the video and figure it out if you don't see where I'm getting these, or you're just plainly marveling at the incredible speed at which I get these, and hopefully they're right. And then, of course, if we chose to do so, and we'll do one in a little more detail in the next video, we'd plot all these points. Very simple. We point the, I'll just do this very roughly. -1. This, now we're plotting the point, we're kind of ignoring t now. This is a regular Cartesian coordinate. So we've got the point -1, 6, 1, 5, 3, 4. I'm just making a rough graph. And 5, 3. And our points kind of go like this. And what's also interesting is each of these points, like the point 1 and 5, is t equals 0, t equals 1, t equals 2. Has this extra feature on the graph. We'll try to get into a little more detail in the next video.